Hey everyone, we're back here in Martinsburg, Ohio, where we're going to do a propane conversion. The propane guys were out this morning, got the tank set and regulator set and ready for me to come in and do changing of the orifices and adjusting the gas pressure for propane. Furnaces only come shipped with for natural gas, so we're going to open this thing up, get them going so they can get this house adjusted to Ohio weather. So we're going to give you a little peep into what takes place. Like I said, the furnace comes shipped with natural gas, but when you convert a furnace to propane, they even ship you burners. The burners are a different stainless burner, and so I'm going to replace the burners. Then they give you a package, has a kit to where you have the orifices and a spring to further the conversion. So you got to replace the orifices, which are the orifices are seated right before they go into the burners here. So there's 1, 2, 3, 4, 5, and then inside this gas valve here, behind this brass right here, we'll remove that. There's a spring down in there. Then we'll hook our manometers up and start adjusting this thing. So that's kind of the basics of it. So we got this unboxed, and I kind of want to show you a little bit of a somewhat, maybe miss a thing or two in what I should say, but a step-by-step for converting your furnace to propane. So we got gas. First thing is you have gas shut off. When you're doing this, you want the power off. We're still in a temporary process on this new home, so I have to wire this up anyway, so obviously power is off. You want to unbox, you want to get your stuff out. We got an installer's guide. Most of us are used to this, but there are some little things that you should at least read over and learn, especially if you installers, service guys. We should be familiar with working with different altitudes, change a lot of factors as far as orifice sizing. These here are the orifices that they send. They're just a brass, they're little brass orifices, and they have markings on them on the face or on the side, and that tells you the size of the orifice hole. On the natural gas, you have a larger size orifice hole, and it's stamped on here. So when we remove these, we'll be able to see a significant difference. Let me just pull one out here and I'll show you as far as what I'm saying. When I call it an orifice it's a hole to which the gas goes through, and it's right there. There's that little hole, and that's actually where your propane gas is going to come through and go into the burner to be ignited on the other side of the burner. And this is where we're replacing these here, and these 4 burners. I said 5 in the initial, but there's only actually 4. So with the instructions, it tells you every manufacturer could be a little different with adjustments. There's a minimum and maximum amount of gas pressure coming into your valve, which is commonly usually 12 or 13 inches water column. You have your output, which you adjust typically around 10 inches water column, but you want to check, read your directions, check for altitude, and even double check to make sure you got the right orifices. So power's off, gas is off. Start removing the gas manifold here. On a perfect situation, you can break this union, pull the whole manifold out to remove these. Since they have the gas line in, it's kind of tight. I'm probably just here going to pull this a little forward, as you can see. And now I can access my orifices to remove them. What I like about that is here these are brass, and so using an adjustable wrench to get on that, it would actually, a lot of times brass is a softer metal and it'll roll that. So it's best to use a socket. And in this situation, because where I'm at, this has a crooked neck. So I'm gonna get in here like this and then be able to remove it. So this here is a 45. I believe it's what it's showing. Yeah, 45 stamped on the face. Look at the hole difference from the propane one that I'm installing. And so we have different markings, numbers, and different hole sizes. It's pretty obvious, but sometimes this isn't black. They'll both be the brass color. So can't really go wrong. Be sure to keep going. Now, there's a lot of things you can do. A lot of times when you look at the threads on here, if you want to come up here and look, it's kind of neat, like in one app inside of it. You know when you tighten something, there's a discoloration. I don't know if you can actually get that or not, but there's a lighter where there's the torque or the tension on the threads. Up here at the top, it's darker and lighter. You want to pay attention when you're tightening in this orifice into the manifold, not to make it loose, but you don't want to over tighten it. You kind of want to make sure, get a marking of where these are set and put them in the same position. So we're going to keep going. That seemed a little more successful. The goal, the homeowner or the builder wanted this furnace up and going for sure. And we've had a little bit of, I had some difficulty. I ordered a kit, this LP conversion kit. Comes with the orifices. In the beginning of the video I was showing you, comes with the burners. They sent the wrong kit. And you know, we had it mailed to the shop and opened it up, everything looked good, felt good. But I noticed I was missing a spring, and one of the springs that go in the gas valve for the two-stage gas valve. So didn't have that, so I just jumped the gun and I got in the truck and went and got another spring and thought no big deal. Well, this was an older kit where the older in the older furnaces, the burners are longer, so burner's not going to work. But it's a good thing to tell you something. The burners that come shipped with the newer furnaces or come shipped for natural gas, we're going to use them anyways. Why? Because we have to. Second, it's not going to like do any kind of functional damage at all. It's just long-term damage it'll do, because the burners that come in the new kit, which we're going to get and come back, they're a stainless steel. The LP burners are stainless steel because of the LP. It does burn hotter, but also has more of a corrosive moisture effect on the burners, and they rust out, especially here on the crossover tube as they light right here. It burns out the tip here, but they rust out. You service guys, you definitely long-term, you know that. I've seen it too many times. LP is corrosive, it's moisture, and no matter what they say or what you read. And so nevertheless, we're to the point. We got the orifices in. The kit orifices were correct. We got another spring. We are getting another kit to replace the burners, but for right now, we're going to run the natural gas ones just temporarily for a week. So that's kind of where we're at. We're going to finish the project. Now we got to put these springs in. When you insert this spring here, it can't be cockeyed, and there's different springs. Like this is a White Rogers gas valve. You can't put a Honeywell spring in. They're larger in diameter, so you can't just put any old LP spring in. But you want to have it fully seated back. And when you got that spring, because this here has this here on that plastic, that has to go down inside of the spring. And so you can't just throw it in there, and if it goes crooked, you're going to throw everything off. So I got it seated right, and what I usually do is, you know, you got to just be careful. This is more than just changing ink in a copier. This is every little fine thing dealing with gas. And to make this precision, if you take your job serious. So we're going to have to get in here. We got one spring in, and this is for the low fire. You see here where it says high? That's for high fire. Low, low fire. This is a two-stage valve. So what I'm going to do is turn this bad boy in 9 times just to kind of get a approximate. 9. Go to the second spring. And you might sense a hurriness in me because I've been running behind chasing a spring around. 2 hours. I had to buy a gas valve, cost $100. They actually gave me a deal because I didn't really complain, but I don't know what another word is for complaining, but $183 for a universal gas valve just to get that spring, because at the supply house they didn't have LP conversion kit that would work here, and I didn't want to drive an hour away, and this was the closest supply house. So I got the spring, paid for that spring, just say a spring, I spent $170 for a spring. But we got to get them going, and it's not the end of the world. Just letting you know that sometimes you got to make choices it's just going to benefit the end of the day. It's going to make the builder happy, get the house warm. They're painting, a lot of things going on, winter's coming. So I'm kind of in a hurry. So we turn that in, 8, 9. Now we got the high and low springs in. We got the orifice in across here. Plug that back in. Now I gotta get my manometer set up, checking the gas pressure, which comes in. So we have gas that comes in. We got LP, we're gonna open this up. It's gonna come down, shoot across, come into this here. And there's what do they call it? An input port and an output port. Gas, you can check the gas coming into the valve and the out. We're gonna set up here, get ready to go. Next is to open our port to check the gas pressure, make sure that the regulator outside is properly set. With usually the LP kits, or it's basically just an Allen wrench here. And then you just want to crack this here, a quarter turn, like so. And once you loosen that, you get out your manometer here. Now, your normal hoses don't fit over that, and a lot of you guys know. So on your LP kits, normally they even come with the tubing, and I usually just start saving the tubing. That tubing sleeves over that there, and then get you ready to plug into your manometer like that. And then that's the input. So this will let me know. So when I open this will tell me the gas pressure coming in, but there's another one that's right below here. And this is the one that's going to tell me, and it's, a lot of guys don't take the screw out. You just turn it quarter, half turn, and then just enough to get the break free the Allen. Now we're going to slide this over, just like that. Nice friction fit, come up, plug into your manometer. This is where it gets fun, especially you tech guys. You know, this is where it gets close to starting it. Just feels really good when you start using the stuff you invest in, your tools, your knowledge. Things just start becoming fun. So we're gonna leave this set here. We're gonna break away, put on the temporary stat, do a little bit of a electrical scenario. Here, pull these back through. Just a little neat little pointer here. You know, sometimes, and I didn't know this for years. I even went to electrical schooling and vocational, young boy. But a lot of times when you wire net, you think you ought to do this and twist this braided wire. You know, actually, what you're supposed to actually do is you just take, when you have stranded wire, you just kind of get this look. You don't want to twist it, so you see a difference. So actually there's a better connection. So when this is in the wire net, so like here, I'll just show you. This is a wire net. So when this is in, it actually, as it turns right, this will automatically twist this wire. So if you do this, it's actually over. I've even done it before where you would do that, or even like say primarily, like say, I'll show you here because we're going to use a solid wire. And so what a lot of people will do is, you don't want to twist the wires together on those either. You just, well, I'll show you how to do that. But anyways, there's just little small things of thought. I just leave my stranded wire. I kind of straighten it out and get a slight twist, but not nothing heavy. Like you can tell the difference there. That's what I do. It's what they say to do. So do it. So now, grab my wire cutters. Just going here. Open up that. Just like that. Okay, now. How much will be inside of there? Just a little score on the wire. Put that back. Typical furnace. For those of you DIYers that's listening in, usually on a 15 or 20 amp breaker. Never over that on a upflow gas furnace, residential world. Put your wire in there. Typically you want about a 1/2 inch of insulation. If you're an electrician out there, you might say that, but basically into a box, whatever, you want to see a little bit of that happening right there. Yeah, we want to get out a tape measure or nothing like that, but you definitely want to have some in. Grab this. Yeah, maybe I'll. Nothing special, but we're just videoing this just to keep you all along with us, keep you entertained. Trying to go as fast as I can, so you won't leave us here and go to another channel. Here we go. You just don't want to be able to pull it out. You don't want to over tighten it. You'll get an idea. Anyways, here we go. Just like that. Now, you and an installer, don't be, I don't know, it's okay like that. Maybe if you like it like that. But whatever you do, try to square everything up, make it look nice. Some of you electricians would say this is what you're supposed to do. And yeah, most of the time, even on new builds, they'll wire it here. But for some reason, an electrician here had left this wire dangling for me, so I don't have, there are other ways you can wire this, not have this connector that I'm using. There's better ways of doing it with connectors. Now, I wish you could see in here, but there's a, just want to tighten that, just like that, nice and tight there. Get your wires going. So this is electrical, this is where the power comes in. This is what we're focusing on. I'm embarrassed to show you my wire strippers here. Some of you are probably not happy with these. There's so many better ones. I want to upgrade, but I'm from an old school era. I just use what I have at some levels, and wire stripper is one of them. So anyway, this is a good example. So we're just going to use this ground wire. Like I said, you don't want to, here, your normal thought is to do this, right? You see how that is? You twist it, but when you put your wire nut on, it pushes that down, look, and then now it's not really a good connection. And then when you do a wire connection, you don't really want this up like this, where this will get up in the wire nut. Wire nut goes into a point down inside there, and it'll just take this, and you're not, okay, so what you do, like this, see how it's even on the top here, right there? It's kind of how you want it. You want to hold it, kind of hold it up close as you can, and so where this, just like that. Grab your wire nut, and keep these level as you're screwing this down. And I usually want to keep this flat, my finger here, and squeeze, and so when the wire twists, it don't twist here, but up inside the wire nut, nice and snug. I know maybe it's overkill for some of you. What I usually do, then I roll it, push it back. Next. You kind of want not too long of wire excess, you kind of want them at the same height there. Okay, roll it. Always keep in mind for vibration, things like that in the future. Okay, now, I mean, it's not drastic, but I don't like that. Like when one wire is either too long, I usually, when they go into the wire now, I think it does a better fit. Kind of get as close as you can eyeball, but you can tell that looks pretty good. There we go. Try to speed this up. Make it a little more exciting. Okay, that's there. Grab a plate. plate back on. Just like that. Remember where you put your screws. Here's that famous sound. Boom. Now, we got the wire. We're going to go upstairs real quick. Meet you upstairs. Well, you couldn't do good if you're colorblind. What would we do if we were colorblind? If you're colorblind out there, I'm not saying it's a bad thing. But how would you know it and how would you do this? So here we go. We're doing temporary stat. Very common stat out there. It's even called temp stat, I believe. Yeah, temp stat. And you can get them. This one here, the TS65, it means 65 is keeps it 65 degrees. And there's 70, 55, and 50, I believe. I don't think it goes any lower or higher. So all you do is do that. Do this. And you, there's no right or wrong as far as which wire. Just do this. Probably got too big of a wire nut, what do you know? What a loser. Let's try this. Sometimes you can fold it. I gotta get the blues. My blue wire nuts. Might work. Okay. But anyways, keeps this at 65 degrees. That means you're not putting on a new stat, guys. It gets beat up, stuff like this. And I want to pull this off and show you, but I'm not. I guess maybe I will. Watch this. Easy. Oh, what's going on? So it looks like, as you see here, how this makes and breaks contact. I believe there's like a capacitor that somehow absorbs, like when it arcs, there's an arc, when it arcs and opens this temporary stat, it's absorbed into a capacitor. Look it up, there's a little more science behind it, but I don't know. It's not rocket science, but it's some other kind of science. There we go. Got that on downstairs. Yeah, we're ready to turn this on. Over here where we're gonna turn on the propane from the tank. They got a shut off here at the regulator. This here is an outside regulator. It can be adjusted by opening this here. But this is a propane regulator. Shut off here. We're going to turn this on like so. Now we got gas going in. Go downstairs, do the rest. So now we're turning on the gas here at the furnace. When it's running, that's obviously off. It just, you can make sense, but when it's running in series or in line, gas comes in, goes in and comes into this valve here. It's very important when it's being tested, guys, to have this shut off. Because if you have too much test pressure on your valve here, it can damage it. So you got the off position here. We're going to turn that to on here. So we got gas coming into our gas valve. We got our gas boss open. They call it a boss, I don't know why, but basically to test the pressure. So we're gonna see what kind of pressure we have coming from the tank. And we're gonna make sure we're in, get a light on maybe. There it is. So we got 11, basically 12 inches water column here. And I know some of you are saying, you didn't zero it, you didn't zero it. I know I didn't. Let's zero it. So let me try this again. I like doing this. Pinch this off. This. So it's actually got gas there, but you can see it is a little bit off. So zeroed it. So you can tell we had like 11.9 something, so we're 12.05. So zeroing it did help. We got 12 coming in, and that's what we need. And that's coming in here on this port. When I fire the furnace, it's going to come in on this hose and tell me the pressure going into the burners. Then we can do the adjustment. The first thing we're going to test is the low, a little bit different here. When it first fires, we got to run at 6 inches water column on this low adjustable spring here. When it kicks in the second stage, or what we call like second fire, this high here on the high stage, we got to adjust it to 10. So 6 and 10. So we'll get out a screwdriver and we're going to turn this on and go. Okay, so we jumpered out. First thing on a 2-stage, you want to adjust the high fire, the second stage one first. You don't adjust the low fire, you adjust the high side first. So let's see what happens here. We probably got a significant amount of air. You can either A, bleed it here by the drip leg, or let it cycle a couple times. I'm probably going to let it cycle. Just a little bit of a tip there. A lot of times you would think to adjust the low fire first, but you adjust the high fire on a 2-stage valve. You always want to make sure before heading out too, you want to put all your little tags to let future service people know. LP, put one on the valve, and you fill out a piece of paper too as far as when it was converted, stuff like that. It's good to mark your tags. This says valve converted to LP. Make it to where it's visible. Put it somewhere, not there probably, but like right here. This looks good. Always try new places that look like it'd be the best. That looks kind of good. Okay, we got a bit of fire action. First, it'll sound like more of a rougher ignition. Go up high, settle, drop down. But if you look here, where we're running, this bottom one here, so this one here on pressure switch 2 is 6 inches. If I told you, if you were listening, or if I think I said so, so on high fire it runs at 10. So with that said, we're at 6. So you turn the high fire screw in, putting pressure on the spring, and you'll see my gauge here should turn up till I get to 10 inches. After you adjust the high fire, then you go to the low fire, and adjust that next, which is 6 inches water pump. We adjusted the high fire first. Now we're adjusting low fire there, and it's manufacturer's calling for 6. So here we go. We're turning clockwise, of course. Righty, tighty, 5.9. There you go. A little tap, a little light tap, maybe. A little left to right, friction. I don't know why I'm always just the way I am with that. Remember them old analog gauges? Some of you remember the yellow jackets? Put on a manometer there, we tap on them, friction. I think even they mentioned doing that real lightly. Of course, then for a final commission, you want to use your combustion analyzer. We're doing a temporary here, then we'll fine-tune this furnace here in the ultimate end. It's evening time, as always for me, getting this builder heat so they can keep going. The LP, just for maybe some of you out there, is burns about 2.5 times hotter than natural gas. There's a lot of benefits. It's actually more what they consider more green. Gas is more filtered, stripped down. LP is not. Okay, so there we go. I'm going to shut it down here. Shut the gas off. Pull this off the boss here. Tighten up where we had our gauges on. I just got to finish the drain, the condensate drain. It was kind of in a temporary run into a bucket here while we're testing all this, but typically on American Standard furnace we got about 10 minutes and it goes into high fire if you just have it jumpered from W1, W2. So anyways, we got that all on. So up here we're just going to check some of our supplies, some of our wall stacks. On this particular house we ran wall stack on the outside wall. Wall stack is a supply run, meaning wall stack, it's put inside the wall, and this is where it's at. So our heat will come up here, and so I'm just checking it just kind of encourages you to see, you know, how good of airflow you got. It feels really good right off the bat before we do an air balance. It's good that we got dampers in each run. Each supply run has a damper. We air balance everything, but before that, it's like this one seems a little bit on the minimal side. So like I said, air balancing, correcting. It's a little further down the trunk line. I'll have to check into that. I'll run over here and check into this. Looks like this will be a little bedroom of some sort. Down here at the end, this is almost close. I know I have not all the ductwork completed, so I'm losing some airflow. It still fills in a minimal place. Some air balancing for sure, pushing towards the end here. But I think we're going to definitely be able to pull it off because we designed this ductwork. It's going to work. It's just, I don't know. So here's where we are. This here's a common problem. You got like a loft area upstairs. You've got a lot of heat that's going up, and it likes to migrate up here. So putting in, we got to return high as we can there, and then also we have the way you put your supplies to be able to take care of this. Usually we always, you know, of course electricians put a fan, but then if you look here, we also put a return to my left here. If you look up here on the wall, right away, real close to the loft area, we're drawing that heat to come up over to here to grab that thing to return back, so it's not like migrating heat up here. Yeah, I think it's better air conditioning and as well. So we're not completed with the ductwork, primarily what we call a pipe out. We got most of all of our return and supply trunks pretty much up. The pipe out is what leaves the supply and return trunks and go out to our supply vents or returns. We're not 100% on that, so we're somewhat just needing to get heat in this process. So this trunk line is air is being pushed in here, and then you come to this, we call it trunk reducer, and then it enlarges here and comes back to the furnace. So this trunk reducer is to reduce the airflow in the trunk line, keeping the velocity going that way. And so you need to know, it's not just putting up metal, but it is kind of knowing how much air can this size duct handle, and how much do you need to properly design to create what we call a static friction in the duct. How much do you need to adequately not have high static friction, but to not have to be able to push the air out to the supply runs and have it designed properly. Because a couple things it does do when you design your ductwork properly, it allows for the blower motor, the longer, basically the blower motor as far as the way it's designed, so it won't die prematurely or go out. And also the furnace and everything as far as overheating, the air conditioning, distributing, humidification, on and on. It's just the air quality, the ductwork has to do a lot with that, and so it's very important to know what you're doing. So anyways, you come down here, this is just your standard plenum. If you look at one of our shorts, we got one on how to fabricate a plenum. This would be a plenum box here. This would be an evaporator coil where your air conditioner lines will hook up here. Here's the air conditioner coil, and this is the actual furnace part. The cold air return is where it brings the fan is drawing the air from upstairs down in, being filtered through this Aprilaire filter here, like so. And if you look at on one of our shorts, we showed you you got to know which direction your air is going. So the air comes down and goes into the furnace. So you can draw a little arrow right there or whatever. Just you got to know what you're doing to install your filter. And then it pushes up, comes in through your supply trunk line. Here we got a typical 90 coming down to run alongside here. And you can see we've reduced down here to even a smaller one. We did put our cap on here. I've got to give you maybe an opening look on this here. This is what it would look like before you put a reducer on it. We got to yet do that. So we're dumping some air down in here. Like I said, we're not finished. Soon to be. Yeah, this is just your typical. And if you look, come down here, this is a top takeoff, meaning, what does that mean? Because it sits on the top of the duct and it's taken off, meaning it's taken off and doing what? It's taken off and going to the supply run where it's going to go up into the upstairs. So actually, where it's going to be is somewhere around in here. There's an island upstairs in the kitchen where it's going to penetrate this flooring. So yeah, there's a way to go about it, and this is the way we went about it. So thanks for tuning in.